Hi everyone, let's see how to do Inorder Traversal iteratively for binary trees. We all know that Inorder Traversal is a depth for traversal. In order to do the Inorder Traversal, we first go to the left node, then visit the root node, and then visit the right node. By following this left root and right thing, we'll achieve the Inorder Traversal. So the Inorder Traversal for the following given tree, as you can see here, is 2, 7, 1, 3 and 5. So let's see how to do it. We'll initialize two variables first. First we'll take current, which will point to the root, and we'll take one stack as well. I'm calling it S here. So we have to keep two important conditions in our mind. The first condition is if current is not none, we'll append the current to the stack and we'll move current to the left. We'll keep doing it until the current reaches none, and if it reaches none, we'll check the length of the stack. If the length of the stack is greater than 0, we'll pop the top of the stack and we'll point our current to it. We'll print the current's data and we'll move our current to the right. Let's see how to achieve it. So now we can see that the current is pointing to the root and it is not none. So we'll append our current to the stack, which is 3 here. We'll move our current to the left as well now. Again, our current is not none, so we'll append our current to the stack and we'll move our current to the left. Again, the current is not none, so we'll append our current to the stack and we'll move our current to the left. Now current is pointing to the none, so now we can follow our second condition. It says the length of the stack is greater than 0. We'll pop the top element of the stack and we'll point our current to it. So the top of the stack here is 2. We'll pop it. We'll point our current to it. Now we'll print current's data, which is 2 here, and we'll move our current to the current's right. Now again the current is pointing to none. We'll follow the second condition. The length of the stack is still greater than 0. We'll pop the top of the stack and we'll point our current to it. We'll pop 7. We'll point the current to it as well. And we'll print our current's data, which is 7, and we'll move our current to current's right. Now the current is not none. We'll follow our first condition. So we'll append 1 to the stack. And we'll move our current to current's left. Now we can see it follows the second condition, as current is pointing to none. The length of the stack is still greater than 0. We'll pop the top of the stack and we'll point our current to it. We'll pop 1. We'll point our current to 1. We'll print our current's data, which is 1. And we'll move current to current's right. So now the current is pointing to null, which is none. So it falls this to the second condition, and we follow the second condition. The length of the stack is still greater than 0. We'll pop the top element of the stack, which is 3 here, and we'll point our current to it as well. And we'll print the current's data, which is 3, and we'll move current to current's right. So now it's not pointing to none. We'll follow the first condition, so we'll append the current to the stack, which is 5, and we'll move our current to current's left. Now as this is pointing to none, we'll go to the second condition and we'll check if length of the stack is greater than, which is, so we'll pop the stack, we'll point our current to it, we'll print current's data, which is 5, and we'll move current to current's right. So as now you can see the current is pointing to none. We'll go to the next condition, but as we can see, the length of the stack is not greater than 0. We have to end our loop here. So in this way we'll do our Inorder Traversal iteratively. If you want to look at the code, it's here. So here we have initialized two variables, current, which is pointing to root. We have taken one stack, and we have used one done variable, which will be true when the length of the stack is not greater than 0 and the current is pointing to none. So while not done, we'll use the first condition. If current is not none, we'll append current to the stack and we'll move current to current's left. Else, if current is pointing to none, we'll check if length of the stack is greater than 0. If it is, we'll pop the stack, the top element of the stack, we'll point current to it, then we'll print current's data, and we'll move our current to current's right. If it is not true, then we'll make done as true, and then we'll come out of the loop, and our Inorder Traversal is done. That's it.